The Bermuda Triangle covers about 500,000 square miles of the Atlantic Ocean, between Florida, Bermuda, and Puerto Rico. It has claimed numerous victims.
Over the last 500 years, the Bermuda Triangle has claimed some 8,000 lives and hundreds of ships and airplanes, none with a definitive cause. But in 2019, a shocking new theory emerges thanks to a scientist who experienced a surprising event in the area.
For decades, the Bermuda Triangle has been linked to disappearances, strange sightings, and mysteries that refuse to die. Most of those stories eventually found logical explanations, but in 2001, a deep-sea survey team made a discovery that left even experienced researchers speechless. At 700 meters below the surface, sonar detected something so unusual that it was verified multiple times. Then a camera drone descended to investigate, and what appeared on the monitors changed the atmosphere in the room instantly. The reputation and the reality. The Bermuda Triangle covers a huge area of the Atlantic Ocean, stretching between the coast of Florida, the island of Bermuda, and Puerto Rico. For decades, this region has been surrounded by stories of missing ships, vanished airplanes, and strange events that seemed impossible to explain. During the 1970s, the mystery became famous around the world. Books, television specials, and documentaries claimed that something unusual was happening in this part of the ocean. Many people became convinced that the Bermuda Triangle was hiding secrets that science could not understand. But when researchers looked closely at the stories, a different picture began to appear. Many of the disappearances linked to the Bermuda Triangle did not actually happen inside its commonly accepted boundaries. Others took place during severe storms or under dangerous conditions. In many cases, investigators found that human mistakes, equipment failures, or powerful weather systems could explain what happened. Experts also pointed out that this region contains some of the busiest shipping and flight routes in the world. With so much traffic passing through, accidents are bound to happen from time to time. As a result, most scientists today do not believe there is anything supernatural about the Bermuda Triangle. The famous reputation of the area is largely based on myths, misunderstandings, and stories that grew more dramatic each time they were retold. However, there is an important difference between the legend and the ocean itself. The myths may be exaggerated, but the Atlantic Ocean remains one of the least explored places on Earth. Beneath the waves lies a world that is still largely unknown. Vast sections of the seafloor have never been studied in detail, and researchers continue to find unexpected features in the deep. That brings us to an event that took place in 2001. During a government-contracted survey mission, a research team was mapping part of the ocean floor deep within the Bermuda Triangle region. What began as a routine operation quickly turned into something far more unusual. Sonar equipment detected a massive structure nearly 700 meters below the surface. The readings were checked again and again from different angles. Each test produced the same result. Then a camera drone was sent down to investigate. What it recorded would leave the control room completely silent. The 2001 expedition. In 2001, ocean researcher Paulina Zalitsky was leading a survey team working for a company called Advanced Digital Communications. The mission was not focused on mysteries or strange discoveries. It had a simple goal. The Cuban government had hired the team to search for old Spanish shipwrecks in waters near Cuba. Many Spanish ships had crossed these waters hundreds of years earlier, carrying gold, silver, and other valuable cargo. Some of those ships never reached their destinations. Storms, accidents, and navigational mistakes caused many vessels to sink. Over time, the exact locations of some wrecks were lost. The team's job was to find them. This was a professional scientific operation. The expedition was carefully planned and used modern equipment designed for deep-sea exploration. Among the most important tools on board was a high-powered side-scan sonar system. Sonar is one of the main tools scientists use to study the ocean floor. Since much of the deep ocean cannot be seen directly, Researchers use sound waves to create detailed maps of what lies below. The system sends pulses of sound through the water and records the echoes that bounce back from the seafloor. Different materials reflect sound in different ways. Soft surfaces, such as mud and sand, absorb more sound and appear darker on sonar images. Hard surfaces, such as rock, reflect more sound and appear brighter. Sonar can also reveal the shape of objects. If something rises above the surrounding seafloor, it creates a shadow behind it. These shadows help researchers estimate the size, height, and structure of underwater features. For the first part of the expedition, everything appeared normal. The sonar images showed exactly what the team expected to find. There were areas of mud, scattered rocks, and natural formations created by geological processes over thousands of years. The seafloor looked rough and uneven in some places and smooth in others. Nothing stood out as unusual. Hour after hour, the survey continued without any surprises. The crew carefully recorded data and followed their planned search routes. Then, during one routine scan, something appeared on the sonar display. At first, it looked like a mistake, but as the team studied the image more closely, they realized they were looking at something they had never expected to find. What the sonar found. The image that appeared on the sonar screen was unlike anything the team had seen during the survey. Up to that point, the seafloor had looked exactly as expected. There were patches of mud, scattered rocks, and natural formations shaped by currents and geological activity. The patterns were irregular and random, just as scientists would expect from nature. This new sonar return was different. The display showed a series of long, straight lines. The spacing between them appeared almost perfectly equal. Some of the lines seemed to meet at angles that looked surprisingly close to 90 degrees. Instead of the random shapes usually found on the ocean floor, this pattern appeared organized. The more the researchers looked at it, the more unusual it seemed. Still, nobody on the team rushed to conclusions. Experienced surveyors know that sonar can sometimes produce misleading images. Equipment settings, water conditions, or the angle of a scan can create strange patterns that are not really there. Before considering any extraordinary explanation, the team needed to make sure the data was accurate. Their first response was skepticism. They carefully checked the sonar system for possible errors. Everything appeared to be working normally. Next, they changed the position of the research vessel and scanned the area again from a different angle. The pattern remained. They adjusted the sonar settings and repeated the scan. The pattern remained. They changed the operating frequency and ran another survey pass. Once again, the pattern remained. At this point, the researchers became even more cautious. They decided to approach the target area from several different directions. If the image was being caused by a scanning error, changing the angle should make the pattern disappear or change shape. It did neither. 5 separate scans were conducted from 5 different directions. Each scan produced nearly identical results. The lines appeared in the same locations every time. That was an important moment. The team could no longer dismiss the image as a technical problem. Whatever was creating the sonar return seemed to be physically present on the ocean floor. The researchers then compared the data with records of known underwater features. They checked for matches with shipwrecks, coral formations, rock structures, and other geological patterns commonly found in the region. Nothing matched. The object remained unidentified. With no clear explanation and a growing sense of curiosity, the team made the next logical decision. They would send a camera down to see it with their own eyes. The descent to 700 meters. At 700 meters below the surface, conditions are not compatible with human survival. The water pressure at that depth exceeds 70 atmospheres, meaning the pressure per square inch is roughly 70 times the pressure at the surface. Sending human divers to 700 meters is not operationally feasible. The only way to see what is there is to send a machine. The team deployed a remotely operated vehicle, known as an ROV. These are robotic cameras attached to the research vessel by a cable that carries power down and transmits video back up. The ROV is piloted from the surface by operators watching a live feed from the vehicle's cameras and controlling its position using thrusters. Equipment failure at 700 meters is not recoverable. If the cable parts or the vehicle fails, it stays there. The pre-dive preparations were thorough. Cable condition, power systems, control responsiveness, emergency protocols, floodlights, cameras. The team checked everything they could check before sending the vehicle over the side. The descent took time. The ocean at the surface was lit. As the ROV went down, the light from above faded. By 300 meters, the ambient light was effectively zero. The only illumination came from the ROV's own floodlights, casting a small circle of visibility in all directions surrounded by complete darkness. The seafloor at 700 meters is a world that receives no sunlight, has no reference points that a human observer above would recognize, and where the only way of knowing where you are is through the instruments and the live video feed. The ROV reached the area identified by the sonar at between 680 and 700 meters depth. The team in the control room watched the screens. What the camera showed. The footage that came back from 700 meters was not what the team expected to find. The team expected what most deep seafloor looks like in the region: mud and sediment covering an uneven limestone substrate, scattered with the irregular shapes of natural rock. What the ROV's cameras showed was different. Large flat surfaces appeared in sequence as the vehicle moved through the area. The surfaces had straight edges. The corners where edges met were sharp, not rounded in the way that natural erosion rounds corners over long periods. The structures were massive. When the ROV moved close enough to provide scale, the vehicle itself appeared small beside the blocks it was filming. Some of the blocks were arranged in lines with near equal spacing between them. The surfaces were smooth in ways that limestone at 700 meters, exposed to ocean conditions over long periods, is not typically smooth. There was surprisingly little erosion and sediment accumulation on some surfaces relative to what would be expected. In the control room, there was silence. The team members watching the footage did not reach for explanations. They watched. The footage was not ambiguous in the way that some underwater anomaly footage is ambiguous. The structures were large enough and the images clear enough that the features were identifiable. Whether those features were the result of natural processes or something else was a question the footage raised clearly. It was not a question the footage answered. 3 natural explanations. The team was composed of professional scientists and engineers who understood that unusual-looking features on the seafloor are more likely to have natural explanations than anomalous ones. Before reaching any conclusions about what they had found, they worked through the geological explanations systematically. The first candidate explanation was ocean currents. Currents moving along the seafloor carry sediment and abrasive particles that wear rock surfaces over long periods. Under specific conditions, this erosion can produce flat surfaces and regular-looking patterns. The problem with applying this explanation to the structures in the footage was directional. Ocean currents scatter material and wear surfaces unevenly across the landscape. They do not organize blocks into lines with equal spacing. The spatial arrangement of the structures in the footage was not consistent with current-produced erosion. The second candidate was volcanic activity. When lava flows into water and cools rapidly, it can produce formations that look organized and regular. The edges of cooling lava can be straight. Multiple flows can produce layered formations that look constructed. The problem with this explanation was the quality of the edges in the footage. Volcanic formations produce irregular edges. The edges visible in the footage were too clean and too consistent to match the typical profile of volcanic cooling formations. The third candidate was tectonic forces. The movement of tectonic plates can fracture, shift, and reposition large sections of seafloor over geological timescales. Tectonic forces can break limestone into large blocks and move those blocks relative to each other. The problem was the spacing. Tectonic fracturing and movement produces irregular results. It does not produce blocks with near equal spacing arranged in lines. The regularity of the spatial arrangement was not consistent with the kinds of outcomes that tectonic forces typically produce. The geological record for the area added another complication. The seafloor in the region is primarily limestone. Limestone is a sedimentary rock that is relatively soft and subject to significant erosion over long timescales, particularly in the presence of water. The surfaces in the footage showed less erosion than limestone at that age, and in those conditions would be expected to show. None of the three natural explanations fully accounted for everything in the footage. What the experts said. When the footage and sonar data were shared with outside experts, the responses reflected a spectrum that ran from cautious engagement to calls for more investigation, with nobody willing to commit definitively to either a fully natural or a clearly anomalous explanation. One expert who reviewed the material took the position that natural processes have a documented capacity to produce formations that mimic constructed structures. The human visual system, trained through experience with built environments, is especially good at recognizing patterns associated with construction, sometimes to the point of finding them in genuinely natural formations. From this perspective, the data was not strong enough to fully rule out an anomalous explanation, but it was also not strong enough to require one. A second expert took a different position. Unusual repeating patterns with consistent geometry in a geological context, where the expected natural explanations do not fully account for the observed features, should not be dismissed without serious investigation. The call was for better scanning, more surveys, and dedicated attention from a larger team with appropriate expertise. The point was not that the structures were definitely man-made. The point was that the data justified taking the question seriously rather than filing it away. The larger implication that both experts circled without landing on was the same one. If the structures are not natural, and if they are as old as they would need to be to explain how they came to be at 700 meters depth, then what they represent would require rethinking the established timeline of human civilization in a fundamental way. The skeptical case. The skeptical position on the 2001 findings has genuine scientific weight and deserves honest engagement rather than dismissal. The most technically grounded skeptical explanation is geological jointing. Jointing is a process in which rock fractures under the influence of pressure, temperature variation, and tectonic stress over millions of years. The fractures produced by jointing can be remarkably regular, creating systems of parallel cracks at consistent angles that produce block-like formations. Jointing is well documented in limestone formations and produces natural features that have been mistaken for constructed structures by observers without detailed geological training. The Giant's Causeway in Northern Ireland, which consists of tens of thousands of regular hexagonal basalt columns, is a frequently cited example of natural geological processes producing formations that look almost impossibly regular and constructed. Natural block formation is a related explanation. When rock fractures along joint lines and the resulting blocks shift or settle, the arrangements can resemble walls, floors, or constructed platforms. The human tendency to perceive meaningful patterns in ambiguous visual information, a well-documented cognitive tendency, makes underwater rock formations particularly susceptible to being perceived as man-made when they are not. The third skeptical explanation addresses the sonar data specifically. Sonar imaging is not photography. It produces a representation of the seafloor based on the interpretation of acoustic reflections, and that interpretation is sensitive to the angle of the scan, the distance from the target, the water conditions, and the processing algorithms applied to the raw data. Patterns that appear organized and regular in sonar data can be artifacts of the scanning and processing rather than features of the actual seafloor. All three skeptical explanations are scientifically legitimate. What gives them limited explanatory force in this case is that they account for the sonar data or the visual footage individually, but do not account for both together with equal coherence. The sonar anomaly was detected and confirmed independently before the visual footage was collected. The visual footage showed features consistent with what the sonar indicated. The convergence of two independent data sources on the same features provides more support than either alone would. What the skeptical position correctly identifies is that the findings are not proven. The standard that Robert Ballard, the oceanographer famous for finding the wreck of the Titanic, has articulated for extraordinary underwater claims is relevant here. Extraordinary claims require extraordinary evidence, and extraordinary evidence in this context means physical samples, laboratory testing, isotope dating, and systematic core drilling. None of those steps were taken by the 2001 expedition. Without physical samples that have been laboratory tested, without isotope dating of the materials, without drilling to examine what lies beneath the visible surface features, science cannot establish what these structures are. The absence of that investigation is the most significant gap in the story. The time problem. If the structures at 700 meters are not natural, the question of when they were built leads to a very uncomfortable place. The structures are at 700 meters below the current sea surface. For them to have been built by human beings, they would need to have been built at a time when the location where they sit was above water and accessible to surface-dwelling humans. The question is whether the area was ever above water, and if so, when. The answer involves tectonic history and sea level change. The seafloor in the region has a complex tectonic history. Land that is now submerged can have been above water at some point in the geological past as a result of tectonic subsidence, the slow sinking of land under tectonic forces. The question is whether the specific area was ever above water, at what depth the relevant formation occurred, and what the timeline implies about when human beings could have been there. Sea level change adds another dimension. During the last ice age, which ended approximately 12,000 years ago, global sea levels were lower than they are today by roughly 100 to 130 meters. This means that coastal land now submerged to that depth was above water as recently as 12,000 years ago, well within the span of modern human existence. 700 meters is well beyond the range of Ice Age sea level change, which means that if the structures were built when the location was above water, the geological history of the area itself, specifically tectonic subsidence rather than sea level change, would need to account for the 700-meter depth. Tectonic subsidence can lower land by hundreds of meters, but the time scale over which this typically happens is geological rather than human. The implication of human construction at a location now 700 meters below sea surface, if tectonic subsidence is the relevant mechanism, is a construction date that precedes any known human civilization by a very significant margin. The known archaeological record places the beginning of complex human societies at roughly 7,000 to 10,000 years ago in the Near East, with earlier but simpler cultures extending further back. If the structures were built by human beings, and if they were built when the location was above water, in the geologically plausible sense, the construction would need to have occurred at a period in human prehistory, for which almost no direct evidence survives and about which almost nothing is known. The implication, stated plainly, is that if these structures are man-made, human history as currently understood is significantly incomplete. What the ocean floor still holds. The 2001 expedition is not a settled case, it is an open one. The footage and sonar data have been reviewed. Outside experts have commented. The debate between natural and anomalous explanations has been had, informally, in academic and professional contexts, where the stakes of taking the anomalous position seriously are career-affecting. What has not happened is the systematic follow-up investigation that the findings justify. No research team has returned to the site with the specific mandate and the specific equipment to collect physical samples, date materials, and conduct the kind of comprehensive survey that would allow scientists to move from ambiguity to conclusion. The location is known. The sonar coordinates are documented. The ROV footage exists. The technical barriers to follow-up investigation are significant but not insurmountable. The ocean floor is the largest unexplored territory on Earth. Approximately 80% of it has not been mapped at high resolution, and the percentage that has been visited by cameras and sampled by collection equipment is far smaller. The structures found at 700 meters in the Bermuda Triangle region are one data point in a seafloor that extends across 70% of the planet's surface, most of which has never been looked at. What is down there is genuinely unknown. The history of oceanographic exploration, from the discovery of hydrothermal vent ecosystems in the 1970s to the ongoing documentation of seamounts, ancient river systems, and coastlines now submerged, has repeatedly demonstrated that the ocean floor contains features whose existence was not predicted and whose implications have required significant adjustment in how scientists understand Earth's geological and biological history. The structures at 700 meters in the Bermuda Triangle may be natural formations produced by geological processes that are not yet fully understood in that specific geological context. They may be something else. The only way to know is to go back and look properly. The question it leaves. The Bermuda Triangle's reputation is built on stories. Most of those stories do not survive examination. The 2001 expedition is different from the stories. It is documented professional survey data, collected by a team with legitimate credentials and legitimate equipment on a legitimate contract with a legitimate government client. The footage from 700 meters shows large flat surfaces, straight edges, and block-like structures. The sonar data that detected them was verified 5 times from 5 different directions. The natural explanations examined by the team and by outside experts do not fully account for all features in both data sources simultaneously. The investigation needed to settle the question definitively has not been conducted. The question of whether the structures are natural or not is genuinely open. The question of what they would mean if they are not natural is genuinely significant. If human beings built structures in a location that is now 700 meters below the surface, and if tectonic subsidence is the mechanism that put them there, then the period of human history we know about is not the beginning of human history. It is a chapter in a longer story, whose earlier chapters are on the ocean floor. The ocean is not going to give up that story easily, but it is not hiding it either. It is simply waiting for someone to go and look. A government-contracted research team found a sonar anomaly in the Bermuda Triangle in 2001. They checked it 5 times from 5 different directions. They sent a camera down to 700 meters. The footage showed large flat surfaces, straight edges, and block-like structures that the natural geological explanations do not fully account for. No follow-up investigation has been conducted. The coordinates are known. The footage exists. If this is worth following, subscribe and stay with us for what comes next.